So this is our lecture for Wednesday and Thursday. So today's topic is controlled experiments. So be sure that you are taking notes on your Cornell note sheets under the week 2 for this lesson. So our guiding question, kind of what's leading us through this topic today, is how do scientists design experiments to test how one factor impacts another? So you already finished your Do Now, where you looked at the experimental design for 2 different plants, one with fertilizer and one without fertilizer, and you came up with an idea of how you would set up your experiment. So now we're going to look at another one. We're going to look at what a specific controlled experiment is. So a controlled experiment is just an experiment with an experiment is a scientific procedure undertaken to test a hypothesis. So you come up with a hypothesis, and then you do an experiment to test to see if that hypothesis is something that is true or not. So a controlled experiment, more specifically than just a regular experiment, is an experiment which has 2 groups which are being treated differently. And then they're being compared at the end. So in our example of our Do Now, we had one plant that had fertilizer and one plant that didn't have fertilizer. So one's getting something, one is not getting that something. It's not getting that fertilizer. And then they are being compared to one another in terms of some outcome. So with our plant, the outcome could have been which one grows taller. So reliable controlled experiments have large groups that they are testing. So with our plant, we only had 2 different plants in our experiment, so it wasn't super reliable. If you only have 2 things in an experiment or a controlled experiment, there are many other things that could have impacted the growth of the plant, such as, random chance. So you have to have a large group in order to test it. So our example of controlled experiment, our hypothesis: if we give a vaccine to a group of healthy border collies, they will be less likely to get sick from that disease. So, in our controlled experiment, this is our procedure that we have. You're going to have a veterinarian check a group of 40 dogs for existing disease. You want to make sure that all of these dogs that you are testing don't already have some underlying problem. So we also have a large group, so it's 40 dogs. You're going to give the vaccine to a group of 20 dogs and no vaccine to the other 20. So you're giving half of your sample size of vaccine and the other half no vaccine, so that you can test the 2 against each other. Then you're going to expose all the dogs to that pathogen, to that or that virus, or whatever that vaccine is protecting against. You're going to protect all the dogs to that thing. And then you're going to record how many dogs from each group got sick, and then you're going to analyze that data. Okay, so that's how you would set up a procedure for that. So we have 2 different types of groups. The 2 groups are treated differently by the scientist. So the 2 different types of groups that are being treated differently are independent variable. So the experimental group, or the treatment group, that is the group that receives some type of treatment. So the treatment that we would have given our dogs was a vaccine. The control group does not receive that treatment. Everything else about the dogs is exactly the same, except one group got the vaccine, one group didn't get the vaccine. Okay? So now we have a couple of different types of variables. We have 3 different types. Our independent variable, which we kind of touched on the last slide, but we're going to go in more depth, a dependent variable, and then control variables. So the independent variable is the one that is manipulated, the one that is impacted or that can change. This is what scientists directly changes and wants to find out what happens as a result. The dependent variable is the measured variable. This is what the scientist gathers data on. How many dogs got sick? How many dogs stayed healthy? Okay, so that's our measured variable, the number of dogs that got sick. In controlled experiment, the scientist is testing whether the independent variable, so our vaccine, we're testing that independent variable, causes a change in the dependent variable. I know there's a lot of kind of weird words here. So our independent variable, our vaccine, does it change whether the dogs get sick or not? And then the control variables, that's what we want to remain the same for all the groups. It's not what we're testing. So, for example, we want to make sure that all of these dogs are eating the exact same food. They are all getting enough water. Because if a dog ends up sick, but let's say that dog was given a different type of food and that food upset that dog's stomach or something like that, that's not because of the virus. Sorry. So we're going to go more in detail with this. So we have our dogs. Our control variables, our dog breed, age, background, living conditions, amount and type of food, amount and amount of water. So the independent variable is our vaccine. So we can change that. But with this example, the independent variable is the vaccine. Okay, so one dog is getting the vaccine, another dog is not getting the vaccine. So our control group is the one that's not getting the vaccine. Our experimental group is the one that is getting the vaccine. So the dependent variable is whether or not the dogs got sick after exposure to the disease. So looks like in our case, our control group, the dogs without the vaccine, did get sick. So dogs get sick after exposure. Experimental dogs are healthy after the exposure. Okay, so then these are our results that you're gonna have 2 questions about in a minute. So the control group, the ones without a vaccine, 18 of them were sick after the exposure, and 2 were healthy after. The experimental group, the ones that got the vaccine, 0 were sick after, and 20 were still healthy after. Okay? So go ahead and answer the questions.